one and all. Myself Sreevani, working as an assistant professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal, Hyderabad. So in the today's lecture, we are going to solve some of the problems based on Faraday's law in electromagnetic waves and transmission lines. Right? So before going to solve problems based upon this Faraday's law, let me introduce what is the definition of a Faraday's law and how we can express mathematically this Faraday's law. Now, depending upon that, we'll solve some of the problems based upon this Faraday's law. So, Faraday states that means V EMF is equal to minus d psi by dt. Induced EMF in any closed circuit is directly proportional to the rate of change of magnetic flux linkage factor is defined by Faraday's law. And V EMF is equal to minus d psi by dt. And if we express this in terms of integrals and differential forms, we can write it as del cross E bar equal to minus dou B bar by dou T as the mathematical statement in the point form or differential form. And if you express this one in terms of integrals, then integral L E dot dl is equal to minus d by dt of integral S B dot ds, or which is equal to minus integral S dou B bar by dou T into ds. Okay, so we can use either of these three formulas depending upon the given data, which formula is suitable. Depending upon that, we can select the formulas accordingly. Right? So first, the problem is given on Faraday's law as in free space E equal to 20 cos omega t minus beta x. Generally, in general, that E can be given as E equal to Em plus, or else magnitude in the positive direction, Em plus into cos of omega t minus beta x into Ay wholes per meter is given. In general, we can express the electric field E in terms of that characteristic parameters, propagation characteristics, as E equal to Em plus cos omega t minus beta x into Ay, where omega is the angular frequency of that one and it is expressed radians per second, and beta be the phase constant and which is to be considered in x direction. Positive, the wave which is propagating in positive x direction. And E is generally expressed in volts per meter. Then from this, calculate JD. Means JD is given by here displacement current density, and as we know that JD formula, or mathematically we can write the expression for this displacement current density as JD is equal to dou D bar by dou T, where D bar is the displacement current density and displacement electric flux density or electric displacement, and it is given by here dou D bar by dou T. And as we know that this D bar is given in terms of E as epsilon into E bar, right? So JD equal to dou D bar by dou T, and we know that the relation between flux density and field intensity is given by D bar equal to epsilon into E bar. Now, E is given as 20 cos omega t minus 50 into x ay. So, Em plus magnitude of the vector E is given as 20 and phase function can be written as here cos of omega t minus beta x into ay. Now, from the given, how will you identify which are the values are given means Em plus is equal to 20 and the beta value is given as 50. Okay, so based upon this given, we need to find the displacement current density in the first case and B as H, means magnetic field intensity. In order to find E, we can express E in terms of H, means according to this Faraday's law, then that is del cross E bar equal to minus dou B bar by dou T. And if you express this in terms of H, means which is equal to minus mu into dou H bar by dou T. If you integrate both sides, then it becomes H is to be expressed in terms of E also to be obtained. Now, JD first we need to find, then H value, magnetic field intensity H, and it is to be measured in ampere per meter. And in the part C, we are going to evaluate the value of omega, angular frequency of the free space wave, right? So now, in order to find all such displacement current density and magnetic field intensity H and angular frequency omega, first we will evaluate the equation for JD. So here, in order to find JD is equal to dou D bar by dou T, and which is equal to epsilon into dou E bar by dou T, right? Which is equal to epsilon means that free space medium is given, we just consider in place of epsilon by epsilon naught. Then epsilon naught into dou by dou T of E bar. So E bar is given as, that is 20 cos omega T minus 20 cos omega T minus 50x into AY, right? So this is the value which is given for E. Then substitute in place of E bar by the given E as 20 into cos omega T minus 50x into AY, right? We are differentiating this one with respect to x, means the other terms which are there in the equation are treated to be a constant. Then epsilon naught. As we know that epsilon naught value as 8.854 into 10 power minus 12 into 20 is also extra term, that is 20, and dou by dou T of cos. Differentiation of cos becomes minus sine, then minus sine omega T minus 50x, right, into omega need to obtain, right? So that is the value for JD. So JD is equal to, this is the way we can evaluate the equation for JD as previous one. See, minus 20 omega epsilon naught sine omega T minus 50x into AY ampere per meter square. As we have discussed, see, if you are integrating this one with respect to cos, the function becomes negative, hence which is equal to minus 20 omega, this 20 and this omega, into, in place of this epsilon naught, if you substitute its value, or else directly we can mention it as epsilon naught into sine omega T minus 50x into AY, right? So this is the value to be obtained. Whereas this displacement current density, in general current is measured in amperes, and per density means it can occupy some area, hence we need to measure it as JD is equal to ampere per meter square, right? So this is the way we can measure the displacement current density using electric field intensity. See, from that the first part is to be evaluated. Next we are going to evaluate H. As we know that H is, see, the relation between E and H means, so in order to find that one H, we use del cross E bar is equal to minus dou B bar by dou T, right? So from this, if you want to get the value, that is del cross E bar equal to minus dou B bar by dou T, means del cross E bar is to be obtained as, and x, y, z directions are given, means we need to express this in terms of determinant as in the Cartesian, that is ax, ay, az, dou by dou x, dou by dou y, and dou by dou z, and we need to get here E value to be expressed in terms of ay, means we have got only y component, and x component, z component becomes 0, then this value need to be given as 20 into cos omega T minus 50x, right? So from this we'll be getting the value of del cross E bar. So del cross E bar is equal to ax bar into, then this becomes 0, then dou by dou z of this becomes 0, 0 minus 0, hence minus ay into, then dou by dou x of 0, then dou by dou z of 0, then again this becomes 0, then plus az into. So dou by dou x of this thing, dou by dou x of means 20 to be a constant, then x with respect to we are integrating means this will be becomes minus sine omega T minus 50x into minus 50. Okay, so del cross E bar equal to, so these two becomes 0, and here the minus 20 is there, and from the differentiation we'll be getting again the value as minus 50, then 20 into 50 becomes 10,000, then 1000 into sine omega t minus 50x into az. This is the value of del cross E bar value to be obtained as this one. Now, which is equal to minus dou V bar by dou t equal to 1000 into sine omega t minus 50x is to be obtained. Right? So, we want to get the value of h, means if you express b in terms of h means b is equal to mu into h bar. Right? So, if you express this in terms of h means minus mu into dou h bar by dou t equal to, again the same thing, 1000 into sine omega t minus 50x into az. Then from this, if you take this mu value into this side, then it becomes in the denominator term. And as we know that for a free space medium, mu is nothing but mu naught only. And we know that its value as 4 pi into 10 power minus 7 Henry per meter. Right? We substitute all these values, and if you are considering both sides integration, then here integration differentiation gets cancelled. H is to be expressed and something into the value. Why? Because magnetic field intensity H is to be expressed in terms of vector form. Right? That's why that 0.4 omega epsilon naught cos of omega t minus 50x into az ampere per meter need to be obtained. Why? Because H is to be measured in magnetic field intensity is to be measured in ampere per meter. And now to find the omega value, as we know that to find this omega value, see here, as for a free space medium, velocity of a wave is given by v equal to 1 by root of mu naught into epsilon naught equal to 3 into 10 power 8 meters per second. And from the given, we know that value of beta as 50. And in terms of, to find the omega velocity, in terms of wave velocity, that formula is given by v equal to omega by beta. Right? To find this omega equal to velocity into beta need to be multiplied. And velocity is given as 3 into 10 power 8 into beta as 50, which is equal to 15 into 10 power 9 radians per second. That is the angular frequency value. Angular frequency. That is the value to be considered as here 1.5 into 10 power 10 radians per second, or 15 into 10 power 9 radians per second. This is the way. If E value is given, then depending upon the Faraday's law, we will solve how the H value and displacement current density JD as well as angular frequency as omega. Okay, next, one more problem, again based upon Faraday's law only. In a charge-free region, again charge-free region means we need to consider it as free space region only, and for sigma equal to 0. For a free space medium, the conductivity becomes 0, then sigma equal to 0, epsilon is to be considered as epsilon naught, and mu is to be considered as mu naught. As we know that epsilon naught value is 8.854 into 10 power minus 12, or which is approximately equal to 10 power minus 9 by 36 pi. And we know that mu naught value is 4 pi into 10 power minus 7 Henry per meter. Okay, so calculate, and epsilon equal to epsilon naught, mu equal to mu naught. Now H equal to 5 cos 10 power 11 t minus 4 y into az, and generally this magnetic field intensity H is to be measured in ampere per meter. Right? So H is given as H is equal to 5 into cos 10 power 11 t minus 4y into az ampere per meter. Now in general, the propagation characteristics of a wave, which includes H value, to be written by mathematical equation as H is equal to Hm plus cos of omega t minus beta y into az ampere per meter. Now from this, hm plus means magnitude of this will be given as hm plus is nothing but 5 and omega equal to 10 power 11, and from that beta equal to 4. Right? So this is the way we can consider whatever the given data from the given. Now from this we'll be evaluating first calculate JD. So to find this JD, as we know that JD and D. So in order to find this JD, first we need to evaluate E value. Why? Because see, according to the formula, JD is given by displacement current density JD and dou D bar by dou T. And we know that the relation between D and E is D equal to epsilon into E bar. Right? So D bar is also a vector. Here E bar is also a vector. So to find this D and JD values, we need to find a E. And there is a direct relation between electric field intensity E and the magnetic field intensity as H. That is given by, according to the Faraday's law, that is del cross E bar equal to minus dou B bar by dou T. Okay. Now from this, first we are going to evaluate the E value, and from this we'll be finding the D. Then from this D, we are going to estimate the JD value. Right? And along with that, epsilon R value also we need to find. Where epsilon R is given by means in general, we know that for the epsilon R means epsilon is generally measured in epsilon equal to epsilon naught into epsilon r, and from this epsilon r equal to epsilon by epsilon naught, means where epsilon r is the relative permittivity and epsilon be the permittivity of the material, and epsilon naught be the permittivity of free space medium. Right? So to find first JD and D, we can use the given data as from the H, that is 5 cos 10 power 11 t minus 4y. Okay, so from that, first use Faraday's law, that is del cross E bar equal to minus dou B bar by dou T. Del cross E bar equal to minus dou B bar by dou T. So as we know that minus dou B bar by dou T equal to, and if you substitute B by mu into H, means B bar equal to mu into H bar, then from this B bar equal to mu naught into H bar. Right? So in place of this B bar, if you substitute mu naught B by mu naught, then see dou B bar by dou T can be written as minus mu naught into dou H bar by dou T, which is equal to minus mu naught into dou by dou T of, what is that value? H is given. Hence, from the given it is 5 cos 10 power 11 t minus 4. 5 cos 10 power 11 t minus 4 pi into AZ. Okay. So, this is the value which is to be given for H. See, from the given 5 cos 10 power 11 t minus 4y. So, then minus, and here minus mu naught, and this 5 is to be considered as a constant. Why? Because we are differentiating this one with respect to t, then minus mu naught into 5 dou by dou t of cos function becomes minus sine 10 power 11 t minus 4y into AZ. Okay, so already in the formula itself we have negative, then minus, and this minus is multiplied, then it will be become positive, then 5 mu naught into sine, and few extra factors to be multiplied as the value as omega t, that is 10 power 11. So 5 mu naught into 10 power 11 and sine 10 power 11 t minus 4y into AZ. Okay, so which is equal to, as we know that 5 mu naught means its value is to be obtained as 5 into mu naught value as 4 pi into 10 power minus 7 into 10 power 11 and sine 10 power 11 t minus 4y into AZ. Okay, so which is equal to, see, 4 into 5 20, then again 2 pi into 10 power minus 7 into 10 power 12. So here you're going to get one extra 10, and that 10 into 10 power 11 means it becomes 10 power 12. Then sine 10 power 11t minus 4y into az. Okay, so from this minus dou b bar by dou t means minus mu naught into dou h bar by dou t equal to. So we evaluate the complete thing as, so which is equal to, how you're going to get 2 pi into 10 power 5 sine 10 power 11t minus 4y into az is to be obtained as minus dou b bar by dou t. Okay, so which is equal to, so this is nothing but del cross E bar. So del cross E bar means, as we know that if you expand this one, AX bar, AY bar and AZ bar, dou by dou X, dou by dou Y and dou by dou Z if you consider, and the resultant will be in terms of AZ means that Z component only exists, hence X and Y components becomes 0, and Z component means 2 pi into 10 power 5 sine 10 power 11 t minus 4y. Right? So if you evaluate, you're going to get the value means del cross E bar is to be obtained. To find the value of E, again we need to consider integration for that. Then you're going to get the value of E is to be obtained, which also to be expressed in terms of unit vectors, and the units for E is to be as volts per meter. Right? After evaluating this E value, then we are going to find, why? Because from the given we need to find displacement current density JD and electric flux density D. So after evaluating this thing, we are going to get the value of E, that is electric field intensity E, and it is measured in volts per meter. Now after evaluating, then JD means after evaluating this E value, then JD need to be found, that is JD equal to dou D bar by dou T. And before finding this displacement current density JD, first we are going to evaluate D bar. And we know that D is nothing but D equal to epsilon into E bar for a charge free region means, and we are replacing the epsilon by epsilon naught into E bar. And we know that this epsilon naught value as 8.854 into 10 power minus 12 into the E value which is to be obtained from this. Okay, so this is the way we have got the value of electric flux density. Now from this D, we will be evaluating the equation for value of displacement current density JD, and which is nothing but dou D bar by dou T. Right? So that value need to be substituted here, and again differentiating that one with respect to T, then we'll be getting the value of displacement current density, that is JD. Right? So this is the way from the given means in a charge free region we will be assuming its value as sigma equal to 0, then epsilon equal to epsilon naught and mu equal to mu naught. Now from that the H is to be given as 5 cos 10 power 11 t minus 4 by az ampere per meter. Now from this calculate the remaining values as displacement current density as JD and electric flux density or electric displacement as D. And we know that how to solve this relative permittivity. Then from the given we need to find means in general this epsilon is given by epsilon naught into epsilon r. Now from this epsilon is equal to epsilon naught by epsilon r you are supposed to evaluate, then epsilon by this thing as epsilon naught. To evaluate, you're going to get the relative permittivity of the value need to be obtained. Okay, so and in the given next one is one more problem is based upon again the Faraday's law, that is in a certain region with sigma equal to 0. In a certain region with sigma equal to 0, there is no conductivity in that particular. Hence, we are considering it as almost it is a free space medium like. Hence, sigma equal to 0 and epsilon need to be considered as 6.25 epsilon naught and mu is equal to mu naught. Now, H is to be obtained as 0.6 cos beta x cos 10 power 8 t minus 4y az ampere per meter. So, with sigma equal to 0 and epsilon value as 6.25 epsilon naught. Epsilon equal to 6.25 into epsilon naught means 6.25 into epsilon naught value as 8.854 into 10 power minus 12. Okay. Another problem is also based on Faraday's law. So here, first in a certain region which sigma equal to 0. Sigma equal to 0 means it is said to be sometimes lossless or sometimes it might be free space also. Right? So for a free space medium, as we know that epsilon r is equal to 1 and this is the case, epsilon becomes epsilon naught. But here, this epsilon value is to be multiplied along with the free space permittivity, it is to be multiplied with 6.25. Hence, it is not equal to exactly free space medium. Hence, epsilon equal to 6.25 into epsilon naught. And as we know that its epsilon naught value is 8.854 into 10 power minus 12. And the unit for this is farad per meter. And h is to be given as 0.6 cos beta x into cos 10 power 8 t minus 4y into az ampere per meter. Right? So, which is equal to 0.6 into, here the function is to be defined as cos A cos B. So, the formula for this is cos of A plus B plus cos of A minus B by 2. See, for a cos of A plus B, the formula becomes cos A cos B minus sin A sin B plus cos A cos B minus of minus becomes plus sin A sin B by 2. Right? So, minus sin A sin B and cos sin A sin B gets cancelled. 2 cos A cos B by 2 is to be obtained. If these two gets cancelled, cos A cos B is the resultant one. Okay. So, to write the formula for cos A cos B, we need to consider it as cos of A plus B plus cos of A minus B by 2. So, for that, first if you write cos of A value is to be beta x plus B is 10 power 8 t minus 4y, right? Then into plus cos A again cos beta x minus and B value need to be 10 power 8 t and already in the formula itself negative is there, then minus of minus becomes plus, that is 4y. Cos of beta x minus 10 power 8 t plus 4y, then total into az by, right? So this is the value to be by 2 can be written. So 0.6 by 2 becomes, that is 0.3. Then the total function becomes here cos beta x plus 10 power 8 t minus 4y, then plus cos beta x minus 10 power 8 t plus 4y into az. Okay, this is to be written for the value of h. Now from this h, we need to find beta. Find beta and the corresponding e using Maxwell's equation. Okay, so to find the e value from the given h, we need to use again the Faraday's law. That is del cross e bar equal to minus dou b bar by dou t. So from this, in order to find the h, minus dou b bar by dou t equal to, this can be written as minus mu into dou h bar by dou t. Then here from the given, the value of mu is given by mu equal to mu naught and epsilon need to be considered as 6.25 epsilon naught. See, minus mu naught dou by dou t of the h value, what we have evaluated till now previously. See, on expanding this one, 0.6 cos beta x into cos of 10 power 8t minus 4y into az ampere per meter. Now from this, the value need to be substituted here. Then that is h. Then after evaluating this thing, means the value need to be evaluated for minus dou b bar by dou t, then in terms of h vector as az only. Now to find the e value, see, using Maxwell's equation. Maxwell's equation is nothing but here one of the Maxwell's equation as from the Faraday's law, that is del cross E bar is equal to minus dou B bar by dou T. Right? So after evaluating this dou B bar by dou T, which is to be nothing but here del cross E bar. So the value which is to be obtained has here in terms of z direction. So first determinant form means we are going to write it as ax, ay, az, and partial derivative terms with respect to the three directions as dou by dou x, dou by dou y, and dou by dou z, and x and y components becomes 0. Why? Because all the h value is to be evaluated with respect to the z only. So here the complete h value need to be considered as here 0.6 cos beta x cos 10 power 8t minus 4y. Right? So if I evaluate like this, then substituted in place of az by or whatever the value which we have evaluated in the previous case, or else direct value need to be considered as 0.6 cos beta x into cos of, that is 10 power 8t minus 4y. 10 power 8t minus 4y into az need to be evaluated. So which is equal to. So now upon expanding this one, ax bar into dou by dou y of, there is no answer. Dou by dou y of means 0.6 cos beta x into cos 10 power 8t minus 4y minus, and second thing becomes 0, then minus ay into, if you evaluate the next one with respect to the ax means first row, if you consider first row and second column, dou by dou x of these things means dou by dou x of again 0.6 cos beta x into cos 10 power 8t minus 4y, then dou by dou z of this value becomes 0, then plus az into, and first row, if you consider first row and third column, then the determinant between these two becomes 0. So like this, you are going to evaluate the value of del cross E bar. So after evaluating this del cross E bar, we will consider both sides of the integration to get the value of E. And finally, this E value to be measured in volts per meter, or according to the fundamental definition of a force, it can be expressed as sometimes Newton per Coulomb also. Right? So this is the way we can evaluate in a certain region with sigma equal to 0, epsilon value is given as 6.25 epsilon naught, and mu is given as mu naught, and h is to be written as 0.6 cos beta x cos 10 power 8t minus 4y into az ampere per meter, and from this find the value of beta. So as we know that in order to find here cos omega t means with a sigma equal to 0 means we know that now to find this beta, first we are going to evaluate velocity. So as we know that velocity equal to 1 by root of mu into epsilon naught, which is equal to 1 by root of mu naught into epsilon naught. Mu and epsilon naught values are to be given as epsilon naught is 6.25 into epsilon naught, and mu is mu naught only. 6.25 into epsilon naught into mu naught is to be obtained, right, which is equal to 1 by 6.25 means, as we know that 6.25, 1 by root of 6.25 into 1 by root of mu naught into epsilon naught value is to be approximately given by 3 into 10 power 8 meters per second by 6.25 is 2.5. Right? This is the value to be obtained for velocity v. So 3 into 10 power 8 by 2.5, and this 2.5 is root of 6.25 can be written as here 2.5, and 1 by root of mu naught into epsilon naught value as given by here 3 into 10 power 8. How it is to be obtained means the velocity here, velocity v equal to 1 by root of, for a free space medium, its value is to be multiplied, means in place of epsilon naught and mu naught, by we substitute 8.854 into 10 power minus 12 into and 4 pi into 10 power minus 7 Henry per meter. And if you substitute two values, then its value is to be approximately equal to 3 into 10 power 8 meters per second. This is the value need to be obtained with the help of this mu and epsilon naught values. Okay. Now from this we'll be finding, see from the given, find beta and the corresponding value using Maxwell's equation. So with the help of Faraday's law, we have been evaluated the equation for electric field intensity as E. Now to evaluate, to find the value of beta, so now to find beta in terms of velocity and the wave angular frequency, that is velocity v equal to omega by beta, from this beta equal to, and the omega value need to be considered from the given as here cos of 10 power 8 t minus 4y, means in general that h is to be considered as hm plus into cos omega t minus beta y, right? So now to find here beta value, we'll consider omega value as 10 power 8, right? So if you substitute omega by 10 power 8 by beta value need to be evaluated. So substituted here, beta equal to omega value, which is equal to omega by velocity. So from this beta equal to find beta here, beta equal to omega value we have considered from the given as 10 power 8 by, and velocity as v, means 3 into 10 power 8 by 2.5. So which is equal to beta equal to 10 power 8 by 3 into 10 power 8 into 2.5. And this gets cancelled. Beta need to be 2.5 by 3, and it is approximately value to be obtained, right? So this is the way we can evaluate in a certain region with which sigma equal to 0 need to be considered as here a lossless medium, and from that epsilon and mu value are to be obtained as 6.25 epsilon naught, and mu is to be given by mu into mu naught value, that is 4 pi into 10 power minus 7 for a free space permeability. And from the given here, h is equal to 0.6 cos beta x into cos 10 power 8 t minus 4y az ampere per meter, right? So from this, first we are going to evaluate beta and the corresponding E using Maxwell's equation, right? So in order to find this value, now to find the electric field intensity E from the given h, we will consider the one of the Maxwell's equation for the time varying fields as Faraday's law, and we can consider here a point form or a differential form of the Maxwell's equation, which is to be expressed for the Faraday's law as del cross E bar equal to minus dou B bar by dou T. Or if you consider, instead of considering differential equation or a point form of that Faraday's law, if we consider integral, then that is closed integral L E dot dl is equal to minus integral S dou B bar by dou T into ds. To evaluate this line integral and surface integrals, we need to know some finite amount of limits, that is lower limit and upper limit, to find the exact values of this integral values. That's why always we need to consider integral form of the Maxwell's equation, which is to be written in the time varying fields as Faraday's law, that is del cross E bar equal to minus dou B bar by dou T, right? So from this, first evaluate minus dou B bar by dou T, and as we know that the relation between flux density and field intensity in magnetic fields as minus mu into dou H bar by dou T, and if we substitute in place of mu by mu naught, why? Because from the given mu is nothing but mu naught. Okay, now mu naught into dou by dou T of H bar. So if we evaluate in place of H, the given value need to be substituted, and if you find the del cross E bar, determinant form of that means we are going to get E value to be in terms of Z. Hence, z component only we can consider, and x and y components becomes 0. From that, we'll be evaluating the value of electric field intensity. Now, to find the beta, then first we have considered here velocity value. Why? Because mu and epsilon naught values are need to be given as epsilon is equal to 6.25 into epsilon naught, and mu is given as mu naught here. Okay. So from this, see velocity equal to 1 by root of mu epsilon, and if we substitute here 1 by root of this thing mu by mu naught and epsilon by 6.25 into epsilon naught, and as we know that for a free space velocity, wave velocity is given by 1 by root over. If you substitute epsilon naught and mu naught values, then we are going to get the value is to be as 3 into 10 power 8 meters per second. And use this value v to find the value of beta. That is the formula velocity v equal to omega by beta. Wave velocity can be written as or phase velocity omega by beta. Now from this, beta need to be as omega by velocity. And from the given, if you substitute the value of omega by 10 power 8 and velocity by the value which is to be obtained as here, then 10 power 8 by 3 into 10 power 8 by 2.5. And from this, we'll be getting the value for phase constant beta is nothing but 2.5 by 3. Right? So this is the way we have evaluated some of the problems based upon Faraday's law. To find the Faraday's law here, now to find or now to solve some of the problems based upon this Faraday's law, first we need to know the relations between D and E and B and H, along with that the point form or differential form and integral form of Maxwell's equation in time varying fields as Faraday's law. As we know that electric flux density D and electric field intensity E as D bar equal to epsilon into E bar, and B bar is nothing but mu into H bar. Why? Because flux density, electric flux density and magnetic flux density need to be vectors. Similarly, electric field intensity and magnetic field intensity both are representing vectors. And by including JD also, as we know that J is the notation for current density and JD is resembles here displacement current density, and it is given by dou D bar by dou T. And as we know that if you substitute D bar by this thing, then epsilon into dou E bar by dou T. To find the exact value of JD is given. To find the exact value of E, we need to consider both sides integration. Then from that, we'll be getting the value of E. Suppose if E value is given, to find JD, again we need to first differentiate this equation with respect to E is given, then to get the value of this JD. And as we know that D can be measured in coulomb per meter square and flux density B bar can be measured in Weber per meter square, and this JD is measured in ampere per meter square. And we can use one of the Maxwell's equation for the time varying fields as that is del cross E bar equal to minus dou B bar by dou T. Okay. So from this, this is the point form or integral form of the time varying fields of from the Faraday's law. Or if you want to find the integral form, that is integral L E bar dot dl bar is equal to minus integral S dou B bar by dou T into dx. Right? To evaluate this one, we need to consider one closed conducting path along with differential surface area also. So if you compare with this point form or differential form to the integral, then it is easy to evaluate or it is easy to solve problems based upon this Faraday's law. That's why always we can use point form or differential form of the Faraday's law just to be expressed in the time varying fields need to be applied or to solve the problems based upon this Faraday's law. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.